Hello and welcome to this big science of the week. Now, topic this week is one that's very much in our minds at the moment, the production of a new TV drama documentary about Chernobyl. So I thought what I'd do, I would explain in relatively simple terms exactly what happened in 1986 at Chernobyl. And there's three questions I'm going to approach here. What happens at a nuclear power station? What actually happened at Chernobyl itself? And is Chernobyl now safe? So let's start looking at what happens at a nuclear power station. Well, it all depends on what's called fission. There's a nuclear fission. A neutron here strikes the nucleus of a heavier nucleus here. This is uranium-235, and this becomes unstable. What it does, it splits to form two lighter nuclei. As it does so, it releases two or three neutrons. Now, the emitted neutrons then go on to split other nuclei, and so on and so on. And what we call a chain reaction. And in this chain reaction releases huge amounts of energy. That's exactly what we want. Okay, so a nuclear power station, we want these chain reactions to produce lots and lots of energy for us. But reactions like this need to be controlled. So how can we achieve this? Well, the energy from nuclear chain reactions is used to heat water. So cold water comes in here, passes over the nuclear fuel rods. They're very, very hot. They heat the water and it forms steam. The steam is then let out of the reactor to drive turbines, which drive generators, and so they make electricity. Now, in many reactors, the fuel is what's called uranium dioxide, which is natural uranium enriched with uranium-235. The fuel is in sealed tubes. Now, to slow down and contain the rate of reaction, water fills this vessel here and acts as a moderator, slowing down the neutrons. In addition, there are also what are called control rods, and these control rods are really, really important. They contain what's called boron or cadmium, and they can be raised or lowered between the nuclear fuel tubes. Now, these absorb neutrons, so they control, as they move, the rate of reaction. You want the reaction to proceed quickly. Okay, you raise the rods out, neutrons are passing back and forth. If you want to contain it, you then lower the rods back in between the nuclear fuel, and that absorbs the neutrons, so slowing down the nuclear reaction. Now, the fuel rods must be replaced every 3 or 4 years. The whole process is highly automated. No one goes near these rods because they're highly radioactive. And that causes a problem because we've got the safe disposal of spent nuclear material, and it's still a huge environmental problem. That is one of the drawbacks of using nuclear energy in terms of for generating electricity. But that gives you an overview there of what actually happens in a nuclear power station. So, what happened at Chernobyl? Well, engineers are actually carrying out a series of safety checks. So what they were doing, they were raising and lowering these control rods between the nuclear fuel elements. But as they tried to put the rods back in between the nuclear fuel elements here, there was a reaction, a fusion here, and the rods got stuck in this position. They couldn't be lowered. Now, what that meant was they had no way of controlling nuclear reactions, and they actually went totally out of control. This produced huge amounts of heat energy, and the core actually went into meltdown. So much energy was produced, an explosion blew the roof off, covering the reactor. So radiation escaped from the reactor, and over the next few days, radiation clouds spread. There was a wind blowing in this direction, and the radiation spread over Europe. Now, that's pretty bad, but it could have been a lot worse, because beneath the reactor here there was a very large tank that was filled with coolant water. Now, if the hot nuclear material here had burned its way through the reactor floor, the really hot nuclear material would have hit the cold water. There would have been a massive, what's called thermonuclear explosion. Now, if that had happened, then for thousands of kilometres there would have been devastation and would have killed thousands and thousands of people. But 2 Russian soldiers, incredible bravery, saved the day. What they did, they dived into this coolant water here knowing it was going to eventually kill them. They opened the taps, releasing the water, so this thermonuclear explosion never happened. But if it hadn't been for those 2 Russian soldiers, it could have been far worse. So, is Chernobyl now safe? Well, there is still a 30-kilometre exclusion zone around Chernobyl. Only if you are permitted can you actually pass through and get anywhere near the reactor. The core of the reactor will remain highly dangerous for tens of thousands of years. No one's going to go near it for many years. And recently they directed this huge containment building here. It was actually built and then pulled over the core reactor here. And that's the idea of this containment building, is it will prevent further leaks and also enable robots to go into the reactor building and start dismantling the core. So that's my take on Chernobyl. I hope it explains to you in simple terms what happened and how bad it could have been if things had taken a turn for the worse. So I'm Graham Bray, and thanks for watching and listening to my big science of the week, and I look forward to speaking again soon. Bye bye for now.